Welcome to the lesson. We are around 59 students who have joined in these past 13 minutes. Kindly join with your video. William Mutua, kindly open your video. Ivan Kerry, fungua video tuonane macho kwa macho Ligan, eka video tuone. Humphrey, fungua video. Najib Malim, fungua video tuone. Donaire, open your videos. Kama unajua umefunga video fungua video. We have 65 students. Bado hatujafika hata quarter Yes, Crispus Mrogi, how are you?
Fine sir.
That's good. Wacha tuone ikifika na 20 minutes tuone ni wangapi tutakuwa nao tuendelee. Yes, William Mutua.
Yes sir.
Naendelea aje?
Salama sana.
Sawa, hata mimi niko sawa. Emmanuel, fungua video. Andrew Kariuki, fungua video. Ian Kaboro, fungua video ni kuone. Najua wengine hata sijui kama naweza wakumbuka. Naweza ukificha video. Mugambi, fungua video. Ngoge, fungua video. I want to start na wengine sioni. At this time they are supposed to have joined. I've disabled the waiting room, so whoever is joining, kindly text your colleagues in your wall and that the lesson is on. Yes, Najib Marim, naona uko area .73 students. Yes, Humphrey. Yes, Humphrey, how are you?
I'm fine.
Na kwani hao wenzenu wako wapi?
Anakuja.
Hawataki hii lesson ama ni nini?
Anakuja karibu.
Lakini lesson tayari imeanza. Ile kazi nilipeana jana umefanya? Ni Wednesday.
Wednesday siku attend.
Aya. Okay. Na Jeff. Philip. How are you?
Niko. I'm fine. I'm fine.
Okay. Ukifanya ile kazi nilisema tufanye ama haukuwa kwa mtandao ile time?
Bundles ziliisha mapema. This time.
Naona sasa ulifika mapema Yes, keep up Wakati nikifungua nilipata tu save ya Ndiakoon. We, Daniel Baraka. Kwa nini hutaki nikuone? Fungua video. Kweli tutasoma hivyo? Assuming you are in class Assuming you are in class na kila mtu amejifunika. Tutasoma aje ama mimi nijifunike?
Cheki. Wi-Fi iko down, so I'm using bundles na ukiwasha video na unatumia bundles inaendanga haraka.
Okay. Sawa. So hata mimi ni save kudata twangu nizime video. Usijali, masomo iko expensive sana to student it is already to 20. I think we can start off so that wengine watatupata tukiendelea. Si sawa? Okay, so yesterday on Wednesday we were doing polymers. We were looking at examples of polymers that are formed through addition polymerization. We were able to see some examples and more important, their uses. So we are still on, to continue with that. Then we see whether we'll be able to clear this docket of organic chemistry. So I'm going to share the screen, see whether you are able to draw the monomers, the open structural formulas of the monomer that forms a rubber. We have two types. We have natural rubber, we have synthetic rubber. Just to confirm, I want to hear from Crispus Moroki. Are you able to see the page that I'm sharing?
Yes, clearly.
Good. So we can continue. So we have two types of rubber. We have natural rubber that is formed naturally, and then we have artificial rubber. So what is important to note, natural rubber, the name of the natural rubber, the systematic name is poly 2-methyl butyl-1,3-diene. So I said we only add the prefix poly to show that it's a polymer. So you can name it as poly 2-methyl butyl-1,3-diene. So it's either you name it as rubber, that is the polymer, or the systematic name, poly 2-methyl butyl-1,3-diene. So note the condensed structural formula here, and note the open structural formula here. So we are talking of, so this is the monomer, not the polymer. This is the monomer, that is 2-methyl butyl-1,3-diene. So we are talking of 2 methyl, so position 1, 2, there is a methyl there, a CH3. Then it is a but, so it's containing 4 carbon atoms, 1, 2, 3, 4. Position 1 and position 3, we have double bonds. So we are talking of the diene, meaning it has 2 double bonds. So this rubber is obtained from latex. So naturally, there are trees that produce latex, and they are referred to as rubber tree. So this latex is obtained from rubber trees. I want to see whether I'll be able to share another screen here showing harvesting of rubber. I want to see whether you will be able to see the video from YouTube. So just give me a second. So Moroki, are you able to see that video?
Yeah.
Good. So let me try to. So what is happening? You first of all make a slice on the stem of that rubber tree. Then, as you can see, there is this milky substance. That is what is referred to as latex. Then you tap it. Note that it is just in a liquid format. Let me restart the video. Start by slicing out of the back of stem. So hii kitu inakaa white, the latex liquid form. So wakati ina correctiwa from here, there is a process referred to as coagulation. Coagulate. So I'm saying there is a process called coagulation. You're familiar with that term in
Yes,
biology?
yes.
Yes, good. So there is that process of kind of clotting, So this coagulation process involves addition of an acid, and most preferably acid is methanoic acid. So methanoic acid is added to coagulate that liquid rubber, and what you obtain is the solid. So coagulating will lead to formation of a solid rubber. Then from there, that coagulated rubber is left to coagulate for some time. So during that time, natural rubber polymer is formed, ile kushikana kwa hiyo rubber. So let's go back to what we were looking at. So I'm saying that during the natural polymerization of rubber, in this structure, I want to see now how the polymer is formed. How can you draw an open structural formula to show that this is rubber and that it is a natural rubber? So remember that this 2-methyl-butyl-1,3-diene, the fact that it has double bond, we noted that molecules that have double bond will undergo addition polymerization. So the first thing that happens is the double bond opens. So one of the bond, the weak bond opens, and there is a lone electron that will be left. So in this case, there will be a lone electron after this bond open, the first bond, after it opens, there will be a lone electron there, and there will be a lone electron there. I hope you are able to follow that. Then the second double bond, one of the weak bond opens, and when it opens, there will be an electron there, and there will be an electron there. So note that these two will form a double bond there, while these electrons in the terminal carbons, they'll form the sticky end, such that if we have another molecule like this, then they will be able to add themselves, one on this side and the other one on the other side. So that means between this carbon number 2 and carbon number 3, there will be double bond. The fact that there was this electron here and a lone electron there after this bond and this bond open. Yeah? So finally what we are going to have after the bond opening is that these are two molecules of the 2-methyl but 1,3-diene, and where they are joining is at this point. Two of them are joining at this point. That's where they are joining. Eh? Because I said in the first case, the first step is the double bond opening. Ya kwanza ilikuwa hapa. So ikifunguka ikaacha an electron hapa. So each carbon obtain its electron, the one that had been sharing in the pi bond. The same case with this carbon, because hapa pia kulikuwa na a double bond. So moja ikafunguka, so kukabaki na electron hapa, na hiyo ingine ikaingia hapa. So note that hii carbon bado iko na hizi two hydrogen. Ile hydrogen ilikuwa hapa, tukaishift hapa chini, ndio hii. So from there, as I was saying, if we have now two of them, they will join at that point. So kutakuwa na hiyo monoma ya kwanza, alafu at this point tuko na monoma ya pili. So this is the second monomer. Sawa. So if we were to represent now the polymer, not down here, this is what it results. Instead of showing two of them, we just need to show one of them. So where we are talking of a sticky end, so nilisema tutakuwa na that rectangular bracket. So in your case, when you are drawing it in your, for example, if it is an exam, you need to show that they are elongated in that manner, that they are cutting across that. Then we put that end there. It's very correct. Right? So therefore, the new bond is formed hapa katikati, carbon number 2 na carbon number 3. So this is our polymer. Okay. Any question up to that point where we are doing formation of natural rubber? polymer or a 2-methyl butane or just rubber? If you have a question, you raise your hand. Good. So let's continue. If there is no question. Okay, so let's move on. So we talked of a process called vulcanization that is referred to as hardening of rubber. You make it harder, you make it more tougher because some of its use require it when it is very hard. For example, making of car tires, there is that hardened rubber. So you heat a mixture of rubber and sulfur. So what happens? So see whether you are able to obtain these. So during vulcanization of the sulfur atoms forms a close ring between chains of rubber molecules or polymers. These will decrease the number of carbon-carbon double bond in the polymer. So looking at these, see whether the sulfur atoms are linking. So number one, what first of all happens is that the double bond opens. So for example, in this structure above here is showing 2 molecules. These are 2 monomers whereby they have joined at this point. They have joined at this point. So there is this one and there is this one. So we have this first polymer, a section of it. If in an exam you are supposed to show with an equation how vulcanization of rubber takes place. That is basically adding sulfur atoms across the molecules. So we have this as the first, a section of the first polymer. While this other one is the second section. We are talking of just a section of the polymer. So in this first case, the first polymer, what happens is that initially we had the double bond at carbon number 2 and carbon number 3. The same case here, this being the carbon number 3, had a double bond there. Number 1, the double bond open, the weak bond open, and it leaves an electron here. Then there is also an electron that will be left there. So the same case on the other side, there will be an electron here and an electron there. Such that this diagram is incomplete. We are going to complete it. So what happens in presence of the sulfur atoms? A sulfur atom will bond with this electron, but note that sulfur requires 2 valence electrons. So one of the valence electron of sulfur will bond with the electron from this carbon, as shown in this case. So there was one electron there from sulfur and this one electron. So the two of them forms this covalent bond. On the other hand, the same thing happens. So at this point, we have a sulfur atom there, comes with its valence electron. So that means this sulfur is remaining with 6, is remaining with, is having 7 valence electrons. So it requires 1 more. So what happens is that the other valence electron requires another sulfur atom for it to be stable. That means for the two sections of the polymer, there will be 2 sulfur atoms joining the 2 sections. So the same case with here, there will be a sulfur atom and that will bond with this carbon, because now we can shift the CH3 on the lower side in that manner. So the same case with here. So there will be a sulfur atom, yeah. Then the CH3, we shift it on the lower side. But we can just show one section instead of 2. We can show just the 2 polymers, each one section in that case, so that hapa tuko na sulfur, kuna sulfur ingine, then there is another sulfur, other sulfur, in that manner. So instead of drawing the 2 of them. So the sulfur atoms make close rings between the 2 polymers. Okay. So in an exam, you can you only draw one section instead of the 2, because one section is just showing the close linking of the 2 polymers by sulfur atoms. Okay. So I think if you have a question, you can ask at this point. You can raise your hand. Okay, I'm waiting for question now. Samuel, you have a question? Yes,
So I was
Samuel.
asking whether we are still talking about polyisoprene.
That's the other name.
Okay.
But yes, but the most common name is poly2-methyl-but 1,3-diene. We are talking of the natural rubber, not the other one.
Oh,
We
okay.
have natural rubber and we have synthetic.
Yes.
Yeah.
Oh, that was my question.
Oh, so basi. Anyone else with a question before we move on? Okay, so I think we can move on. So the other type of rubber is synthetic, sorry. So before that, vulcanized rubber is used to make tires, shoes, and valves. Sometimes they may ask you why vulcanized rubber is preferred in making tires or the shoes or the valves. The reason is because vulcanized rubber is harder and more tough. Okay, synthetic rubber, the monomer of synthetic rubber So these are rubbers that are manufactured in the laboratory or in industries. The monomers, they use 2-chloro-butane, or what is called isoprene. So synthetic rubber, the monomer is 2-chloro-butane. And look at the condensed structural formula and the open structural formula. So the only difference there is the halogen group there, substituted with amyl. So the same process happens. The opening of the double bond, from there, like in this case, we have these two molecules. Because ya kwanza imefika at this point, 1, 2, 3, 4, imefika hapo. So that means, so if you have a question, you ask. You raise your hand. So the same process happens as in the case of the natural rubber, 2-methyl-butane. The same case happens with 2-chloro-butane. So the first thing is the double bond opening, and it opens. There will be an electron that will be left in the second. There will be an electron there. In that case, and that's double bond open. There is an electron there. Then there will be another electron there. On the other side, the same case, that double bond, one of the double bond opens, an electron is left there in those 2 points. The 2 electrons attract each other, they collapse and they form a pi bond, which is seen at this point. So in the other molecule, this is the new bond that is formed. So that means the one electron here and the other one electron in the second molecule, they form a double bond. So we have a sticky end on this side or in this side. So instead of showing the 2 of them, we can show one, like in this case. So we only take one of them, then we represent it in this manner. The same case. So note that structures. So the only difference is that a functional group of halogen. So this synthetic rubber can still be vulcanized. So that means you will still undergo the same process as the natural rubber. So it can also be hardened by vulcanization. So the same process, okay? Okay, so from there, let's continue to the next type of polymerization, that is condensation polymerization. And condensation polymerization involves 2 or more monomers joining together to form a large molecule by elimination or removal of simple molecules, most common water. So in this case, we had seen the first one, nylon 6,6, we had dealt with that. And nylon 6,6, the monomers is hexane 1,6 dioic acid and hexane 1,6 diamine. So I believe you remember that. We dealt with that. Let's see the two of them, the process. So condensation polymerization normally involves two monomers. These monomers may be different or may be different or may be similar. A common thing in the monomers is that they must have functional group on either end. So that is a characteristic of monomers that forms polymers under process of condensation. It involves two monomers. The monomers may be different or they may be similar, and the monomers must have functional group on either end. So those are characteristic of monomers that undergoes condensation polymerization. So other examples of polymers that are formed through condensation or polymerization is like the common disaccharides. We have run that in biology. Examples of disaccharides. Anyone? Which are these examples of disaccharides? Those ones tumesoma in biology. Anyone willing to give us the examples of disaccharides? We have RX.
Sucrose.
Yes, sucrose. That is one example. We have around the other two, eh? Ambazo zingine haukumbuki. Aja tusikie Samuel Gakinya.
Maltose.
We have maltose, eh? Good. Hiyo ingine ya mwisho ni gani? Kuna sucrose, maltose na
Lactose.
lactose. Good. So these disaccharides, they are formed through condensation of monosaccharides. Sindio? Monosaccharides, we are talking of akina glucose. Sindio? So when two glucose molecules combine, your process tunasemanga ni condensation, yes? The two of them join to form a disaccharide. Disaccharide is an example of a polymer. So that means even polysaccharides, they are formed through the same process, condensation polymerization. Yeah? Okay, so the same case here with the nylon is formed through the same process. Eh? So ukiangalia hiyo glucose, and the functional groups of OH ni gani? Someone to answer that. Eh? Functional group of the glucose. Let's hear from Brian. Go out to Brian. Yes, functional group of glucose. Anyone? Okay, so the functional group of glucose are OH, the OH group, the hydroxyl group. So ukiangalia hiyo glucose utapata where they are joining to form the polymers or the polysaccharide, they both have on their ends OH group. So monomers forming polymers through condensation or polymerization may have similar functional groups. So ukiangalia for example this one, hexane 1,6-diamine iko na similar functional group. Hii functional group tunaitanga amine, amine. So when there are two, we are referring to them as diamine. So they may be similar or they may be different. So for example, here hexane 1,6-dioic acid, again the functional groups are similar, but the two of them, they have different functional group. Where they are combining, there is loss of small groups, and especially commonly water molecules are lost. So here tuliangalia na tukaona how water molecule was formed, but you can look at this, see the equation there. So we noted that this acid loses the OH, and the diamine loses that hydrogen, and it is at that point that is where they are going to form a bond. So to show that this is a polymer, we noted that on this side utakuwa na this amine group, and that means OH itatoka, and that means there will be a sticky end. On the other side, hydrogen itatoka, and there will be a sticky end. In that manner, hydrogen itatoka. And from there, we show it with the rectangular bracket in that manner. Then we put an N there to show that it is a polymer. So that is nylon 66. I said why we refer to it as nylon 66 is because the two monomers contains 6 carbon. The two of them contains 6 carbons, and that's why we are referring it to as nylon 66. Any question up to that point? Okay, maybe I ask a question before I reveal what is down there. Tulisema uses of nylon 66 ni zipi? Uses of nylon 66, someone? Uses of nylon 66. Na leo tumekuwa wachache. Last time we had around 130 students. Sasa hizi naona tuko 109. Wengine wako wapi? Uses of nylon 66. Watu wakumbuki, eh? Hey, you guys, you need to be revising, eh? Na kile tumerevise, isikue inapotelea. Najua wengine wetu tukifungulia hizo speakers, zile mambo tutasikia huko background. So I believe that all students are concentrating, eh? Okay, so yes, who is this? Yes, ropes, making of ropes, that is correct. Another use, making of what? Sema clothes. Hata si tunajua kuna nguo zinatengenezwa na nylon, eh? Making of clothes, yes. Carpets, eh? Yeah, that is correct. Good, okay. And that is what we have here, clothes, plastic ropes, and carpets, eh? Yes. Paper bags. Mtu ameandika paper bags. Paper bags zinatengenezwa sana sana na polyethylene. Unajua ile polyethylene? Polyethylene. Yes, kuna mtu anaandika brush. Yes, hiyo that is correct. Brian, that is correct. Haya, sawa sawa. I think for uses, if you know around 3, that is correct. That is okay. Wacha tumalizie this other part. Another example of a polymer that is formed through condensation polymerization is terylene, or what is called polyester. Terylene or polyester is a polymer that is formed through condensation of two molecules, either 1,2-diol and benzene 1,4-dioic acid. Yes. Here the open structures of the monomers, benzene 1,4-dioic acid. So when we talk of benzene, this C6H5, I said you can represent it as a ring. You can put it in this manner, or you can put it as a ring. So you put it as in this manner. That one is still okay. And then you remember to put the circle there. So you stick it at this point. So itakuwa hapo. So this will still be the same. So you can put either of them. That is correct. So note again on each end, there is a functional group. In this case, the CoH, which is an alkanoic acid. If an 1,2-diol, note there is OH in the two end. And then when they are joining, or when they are combining, we have the alcohol, that is the diol. Tunatoa hiyo OH, ina lose the OH, and the dioic, the acid loses this hydrogen. So where they are going to join is at that point. And what is formed is a polymer, and on this side, to represent that it is a polymer, the other side, what is going to happen is that hiyo itatoka na hii itatoka. So that means there will be a bond there and a bond there. Question? Yes, Karaoke, you have a question? Yes, Karaoke, you can unmute yourself. Stand us.
No, I don't have a question.
Oh, so. So the polymer of terylene will be in this manner. So there will be a bond there, and there will be a bond there, then an end there. Point of correction, let me clarify here something. In this molecule, what is happening, so that this polymer is formed is that the acid loses the hydrogen on this side, and the alcohol loses the OH in this side. So this is what is going to be formed. How this polymer is formed is that on this side, the acid will lose the OH, and on the other side, the alcohol will lose the hydrogen. So that this bond, there will be a sticky end there, and on the other side, mahali tumetoa OH, there will be a sticky end there. So this sticky end ndio tutaonyesha na tutakata na hiyo rectangular bracket, then put an end there. On the other side, tunakata hiyo OH inaenda hivyo. So note this is a case of terylene or polyester, how it is formed. Benzene 1,4-dioic acid, when you are showing the formation, ile monomer umechola hapa ya kwanza, and on the other side, the ethane 1,2-diol yenye umechola, where they are going to combine is that the acid will lose the hydrogen and the alcohol will lose the OH. That point, that is where they are going to form the point, the linkage. But to show that it is a polymer, on the other side of each molecule, let's see, for the acid, it loses the OH, and for the alcohol, it loses the hydrogen. So they will go that manner alternating, okay? So be careful when you, in case there is a question of viewers asking you to using an equation show formation of a polymer of terylene or polyester, or just showing the polymer of polyester. Then remember there is plus water there, because when the OH from the ethanol, the ethane 1,2-diol and the hydrogen from the acid combines, they will lead to formation of water. Any question? Okay. So uses of terylene or polyester. It is used in making clothes, plastic gloves, and sails, plastic models, kits. So those are uses of terylene. Someone try to write something there. So if you have a question, raise your hand. Alex Ikonya, kuna swali?
Okay, so I haven't really understood how the polyester is formed.
Okay. So first of all, have you noted that it is formed through condensation of benzene 1,4-dioic acid and ethane 1,2-diol.
Yes.
So this is an alkanoic acid, this is an alcohol. The reaction is a condensation polymerization. But something else that we know is that reaction between an alkano and alkanoic acid, that is referred to as ester.
Yeah.
So why we are therefore referring it to as a polyester is because it is formed through reaction of an alkanoic acid and an alcohol.
Yes.
So we have the formulas of the two monomers, benzene 1,4-dioic acid. In this monomer, kila mwisho kuna the functional group, the OH. Na kwa ethane 1,2-diol kuna the OH groups.
Yeah.
So mahali zina join ndio tunataka kujua ni wapi. Sawa. So these two molecules, ukiangalia hii alkanoic acid, what is formed, tunaona ya kwamba hydrogen imetoka at this point. Sawa.
Yes.
Now on this other side, kwa ethane 1,2-diol, OH imetoka. Of course, hiyo ndio ina lead to formation of water molecule.
Yes.
So on this other side, ndio tuonyesha sasa ni polymer. Unajua tunafaa kuweka hizo rectangular bracket alafu tuweke that ka end, si ndio?
Yeah.
So in this polyester terylene, hii molecule ya kwanza yenye tumechora ya alkanoic acid, kwa hii side ingine ita lose the OH. Sawa.
Sawa.
Na alafu these ethane 1,2-diol, hii mwisho ingine ita lose the hydrogen. Sawa.
Yes.
So that tutacholea hiyo rectangular bracket mahali hiyo hydrogen imetoka, then we put an N. Then on the other side mahali tumetoa hiyo OH, ako ka sticky end ndio tunaonyesha that rectangular bracket in that manner. Lakini sio hydrogen. Sawa. So hata ukiangalia kwa kitabu iko hivyo. So that means kama tuko na molecule nyingine hapa ya alkanoic acid, hiyo alkanoic acid ita lose OH. Sawa. Sababu hii molecule ya ethane 1,2-diol ime lose hydrogen. That means ile alkanoic acid iko hapa ita lose OH ndio ziform water. Sawa. So zinaenda zikialternate hivyo. Hii mwisho ikitoa hydrogen, ile mwisho ingine inatoa OH. Sawa.
Sawa.
So zina alternate hivyo hizo molecules mbili. I hope you have understood that.
Yes, I've understood.
Sawa. So I have one question there. Kindly look at that question. We have two. Two more question. Austin Njura, waje ni wako.
Is sterylene an ester? Because
Yes.
it's combination of is sterylene an ester?
Sterylene is an ester, that is correct. But when we have it as a large molecule, now it will be a polyester. Yes. Any other question? Okay, so I want you to look at that question number 1 there, and I try to answer the question, then you'll give me the answer there. I want to rush to the washroom.
busy. So for the,
Hello, Mr. Gitao.
when you define that place, you
Mr. Gitao, can you hear me? Mr. Gitao. So
Okay. Okay, 5 minutes. Put it is only get one. I want to explain this.